Grade 11s, we're going to spend another day with annuities to make sure that they are sitting comfortably, and also with the TI-83s, because they are something you're expected to do, and with similar computer program would be something very useful to you as you look at money situations in your near future. Maria plans to retire in 8 years. She decides to invest $2,500 at the end of each year for the remaining 8 years she plans to work. And just may I say, that's a little too late, but better something than nothing. Okay, $2,500 at the end of each year. Interest is paid at 6.5% per annum compounded annually. Draw a payment diagram and draw the appropriate sequence. So what is going to happen? Right now, Maria makes her decision. And she has a year to get the $2,500 together. So 1 year from now, she's going to put $2,500 in. 2 years, she's going to put another $2,500 in, all the way to year 7, $2,500 in, and year 8, $2,500 in. Now, some of these deposits have a long time to accumulate some interest. The last one, for instance, isn't going to get any interest because she puts it in and then she retires and she needs it. So this one has a year to get some interest. So we're looking at compound interest, $2,500 in. It's 6.5% annually, so that's easy to write, 1.065 for 1 year of interest. This one has a lot of interest. There's those years in between that we just didn't bother to write down. For year 2, would have 6 years worth of interest. So 2,500, 1.065, 6 years worth of interest. And this one is going to have 7 years worth of interest. We have answered that question, but I suppose more appropriately, what we're used to seeing as a sequence is 2,500, and so on. That looks more like a sequence. Calculate the amount of the annuity at the end of 8 years. First of all, are we convinced that it's an annuity? It is an annuity because she's making regular deposits. It is also an amount that we're looking to find, not present value. Amount or future value, same thing. Because she's making regular deposits towards a distant future amount. We want to find the amount, so our formula will be 1 plus I to the n, subtract 1. They're so similar, you just need to be careful. Annuity singular. There we are. Her regular deposit is $2,500. 1 plus I is 1.065 to the power of 8, subtract 1 over 0.065. And the amount of that annuity, if you were to add all of that up, would be $25,192.14. We are asked to find out how much interest she will have earned from her deposits. So Maria deposited $2,500 8 times, once a year for 8 years. So her money is $20,000. What she ends up with in that account is $25,192.14. So the interest is the difference which is 5,192.14. Gina wants a red Ferrari, and why not? She is willing to spend $19.50 a month for 7 years. And she can get, oops, I need to change this, and can get 4.2% per annum compounded monthly. At this point in your life, those two things need to match. I'm sorry. Because of her excellent credit. How much can she spend on the car? Will she have to settle for a Saturn? Here we go. Gina wants a loan for the Ferrari, a regular payment. It's an annuity because she's going to pay it monthly. And it's a loan, so it is a present value problem. When you want a loan, you want money right now. There. That is the thought process we need to go through for these problems. This is the formula we need for present value. R. 1 minus the rate, the negative n over I. All right, Gina, in your well-paying job, $19.50 she can afford a month for a car. 1 minus. Now it's 4.2% compounded monthly, so we have to adjust for that. 1 plus decimal 0.42 monthly to the negative. It is every month for 7 years. 7 times 12. 84 over whatever this nasty decimal is. Decimal 0.42 over 12. Very carefully, and you may write as many lines as you wish, but be careful of rounding errors. The present value is $141,704.19. If you are having trouble entering that on your calculator, please talk to me tomorrow and we can make sure we can get all that entered correctly in your calculator. If you are struggling, a good strategy is to work from the inside out. So you would type that in first and then you would add 1 second. Put it to the power of negative 84 as your third. And then 1 take away the answer for all of that. Lastly, multiply by 1950 and then divide with that in brackets, and you should get the answer that I have. The present value is $141,704.19. I looked it up. Ferraris are usually about $250,000. So Gina is stuck with a Saturn. Let's do a question that involves 2 steps. Matt wants to save for retirement. Yay, Matt. Very mature decision. He wants to have enough at 65 to take out $450 a month for 20 years. So, a couple of things we see here. Matt's cheap. He is planning to live to 85. And he is really assuming that he can get 5.5% per annum compounded monthly. Secondly, how much does he need to put away a month now if he is 25 and he can invest in an annuity that will earn 6.4% compounded monthly? First thing we need to look at is how much does he need at 65? And then we'll figure out how he's going to get there. When he is 65 years old, he wants $450 a month for 20 years monthly. He is assuming he can get 5.5% monthly. We want to know how much he has to have in order to do that. If he wants a certain amount, at 65 that pays regularly from there, is that a present value problem or an amount problem? That's a present value problem. He wants a certain amount, technically then, but he wants an amount then that from there forward will pay him regularly. So his present value at 65 is what we're looking for. So if you like pictures, Matt is 25 years old. This is the now. He's going to save until he's 65. That will be an amount problem. When he is 65, he wants a present value problem to figure out how much he can live on until he is 85. We're starting right here. We need to know that present value so we can figure out how much we need to save to get there. Okay, our N is 240. So present value is I just always write that formula down. Regular payments, he wants $450. His interest rate is 1 plus decimal 0.55 divided by 12 to the negative 240 over decimal 0.55 over 12. So very carefully entering that into your calculator. The present value is 65,417.69. That's what he needs at 65. We want to get him there. So in order to save to 65,417 at 25, he needs regular payments. We don't know. His interest rate now is 6.4% compounded monthly. He is going to save for 40 years. So that N value is 480. If Matt is saving towards $65,417, that's an amount problem. So amount or future value, same thing, is that 65,417.69 he needs to save towards. So we're doing this by hand first, and then we'll show you on the graphing calculator as well. So he is saving towards 65,417.69. It's regular. 1 plus, this is a new rate, decimal 0.64 over 12 to the 480. Subtract 1 over. Remember, it gets a little ugly when you're solving for R, but you're going to have 65,417.69, multiplying both sides by that denominator. Then I'm going to divide both sides by the ugly square bracket. Very carefully, or with some help from me, you're going to get your regular deposits of $29.45. That's not a lot of money. Matt, I am sure, could manage to put away a little bit more than that, and he will be rolling in it when he's old. Let's have a look at the graphing calculators, make sure we come up with the same numbers. Okay, let's verify that the amount that Matt needs at 65 years of age is in fact the 65,000. Let's look here. So we want to figure out how much he needs at the age of 65. Regular payments that he wants are $450. Those are payments to him, so that would be positive $450. The amount of time that he wants to be able to take these regular payments is for 20 years, and he wants to do it monthly. He's going to be paid and to have it compounded monthly, so both of those are 12s. The future value, when he's all done at 85, he'll be in a home and he'll be cared for by his children, so that future value will be 0. It's the present value that we need to find. Oh, we need the interest rate. The interest rate we are going to put in just as we see it, 5.5%. I'm just checking that all my numbers are correct. Good. We want to know the present value. He wants to know that amount at 65 that will pay out his deposits or his regular payments. So let's alpha enter. 65,417.69. That would come out of his pocket. So he needs that money at 65 in order to pay himself out. Okay, going from there. How much does he need to put away a month now if he is 25 and he needs that as his future value? So while I've got that money in front of me, I'm going to type in 65,417.69 as my future value. My payment is what I don't know, so I'm going to get the calculator to tell me that. He is going to earn monthly and monthly, so those 12s stay the same. The present value when he is 25 years of age is 0. He's got nothing. His interest rate at 25 years of age is 6.4%. And he is planning on making these deposits regularly for 40 years. 40 times 12. What is that regular deposit that he needs? I'm going down to payment. And that's going to come out of his pocket, so that should be negative. Let's make sure we get the same answer. Alpha, enter. Yes, $29.45. If he were to up that amount of money, say he thinks $29.45 is ridiculous, so he's going to go with, oh, I don't know, let's go with $35. Oops, let's make it negative as well. It comes out of his pocket. $35. What will his future value be? $77,000.53. So how much would that allow him to have as an older gentleman? 77,753, 29 cents. 5.5, 20 years. His future value is 0, and I want to know what he will alpha enter. He would be able to have $534 a month if he would just up his payments by $6 a month. I have a review sheet I'd like you to do with your partner where you're not going to do the problems, you're just going to read them and determine whether you have a present value or a future value problem, and if you're solving for R or specifically A or PV. Then some textbook questions would be good.